Hey guys, so welcome back. In the previous video, we created our first Solidity smart contract and deployed it onto Sepolia test network. Alright, and we also test that deployed contract onto our remix using the remix at address feature, which allows you to interact with contracts just by its address on the blockchain. So in the previous video, I went through the whole process of how you can create a contract, deploy it onto the remix local blockchain, or if you want to, you can also deploy it onto an actual test network. But in doing so, I also skipped on some important details which are actually required while you are creating a Solidity smart contract. Alright, so let's just start with the first important detail that we missed is that what is actually happening under the hood when we hit this deploy button. So previously when we were actually creating our own blockchain from scratch and we were actually creating some transactions, so we had to create a transaction object for each sender, like the one who was creating the transaction. So similarly, when you hit deploy on a contract, it gets deployed as a transaction. And as I've told you before that everything and anything that happens on the blockchain always happens as a transaction. Alright, so once you hit the deploy button, a new transaction object is created and it gets deployed onto the blockchain. Alright, so now what does this new transaction object look like? So as we have seen before, when we were creating a transaction object for a normal transaction, it used to contain some input objects and some output objects. So the input object consisted of details about the sender, about his public key and what his initial balance was, while the output properties consisted of how much amount is going to be left in his wallet and how much amount is actually going to get transacted to another public key. But now if we talk about deploying a smart contract, the new transaction object looks completely different. So this new transaction object actually has 9 properties. Alright, nonce, to, data, value, gas price, gas limit, V, R and S. Alright. So now let's first talk about what the nonce value is here. Alright, now this is not your normal nonce. So this is actually the number of how many times the sender has sent a transaction. Now what do I mean by a sender here? Alright, because sometimes in case of these Solidity smart contracts, people actually often get confused of what a sender is. Alright. So the thing is that if you go on to Remix, you actually select the account with which you want to create the transaction or transact something. Alright. So this is actually the account that is the actual sender while you perform any action on a Solidity contract. Alright. So this would be the sender for that specific Solidity smart contract or the deployer for that specific Solidity smart contract. Alright. So the nonce is actually going to get derived from here as to how many times the sender has created a transaction. Alright. So now the next property is to. Alright. So now this is actually left blank. Alright, so if anywhere on the blockchain you see a transaction object that has no to property, so there is no address with which you want to create a transaction with, alright, because you want to deploy a new contract, alright. So anywhere on the blockchain, if you see a transaction object and it has no to property, it means that the person actually wants to deploy a contract. Now the next property is data. Alright, so previously we actually used to include the output objects or actual transaction objects inside the data field. Alright, but while creating a contract, you actually want to include the actual byte code of the Solidity smart contract. Now the byte code for a Solidity smart contract is something that is generated after compiling a smart contract. Alright. So if we head on to the Solidity smart compiler in our remix, and if you look down below with the ABI, you can actually see that it also provides the bytecode for your written Solidity smart contract. Alright, so if you actually click on this, it would actually copy the bytecode for you on your clipboard. Alright, so this is actually the bytecode that gets added as data while creating a transaction object for deploying a smart contract. Now the next parameter is value. Alright, most of the time this field is actually going to be 0. Alright, because there is no going to be initial value attached to a smart contract. But if we hop on to Remix again and look at the field where we are required to pass a value in for our smart contract. Now if you look at the types of value that you can pass in, so you can actually hit this drop down and actually see all the values. So these are nothing but different units of ether. So while deployment, if you actually pass in some value, so what happens is that your smart contract will actually have some cryptocurrency while deployment. Alright, so say if you pass in 5 ether in here and hit deploy, so your contract will actually have stored 5 ether. Alright, And if you have developed your contract in some other way in which you can interact with that 5 ether, then your contract can actually transact with its own address with another accounts. All right. So that is what this value parameter is for. It stores the initial balance which the contract will have after deployment. So the next two parameters are gas price and gas limit. Alright, so I'll talk about gas in just a few moments, but in order to understand the transaction object, you need to know that it contains gas price and gas limit. So the gas price will actually contain the amount that was deducted as gas fees while deployment of your contract. Alright. So as you know that if you perform any operation on the blockchain, you need to pay some fees. All right. So every operation has some gas fees attached to it. So while deployment, you are actually performing some operations on the blockchain. So you need to provide a fees for it. Now this will store the amount of fees that you paid for that particular deployment. Now if we talk about gas limit, is actually the units of gas that is going to get consumed for this particular transaction. Now if we talk about the transactions that we are performing on Remix with the help of MetaMask, the thing is that MetaMask actually automatically calculates the gas limit for you. Alright, so you don't have to pass in the actual gas limit for every transaction, because it would be a headache for the person to calculate the gas amount that is needed for him in order to create that particular transaction. So if we go back onto Remix, you can actually provide the gas limit over here. So if we provide a gas limit that is very, very low, such as 3 or 30, then you won't be able to transact any amount, because obviously the gas fees is going to be greater than that, and you have given a limit as 30. So you won't be allowed to create that transaction, as you are not happy with the amount of gas that is being asked for you to create that particular transaction. All right. So in here, the default is actually a huge number. So every time you actually create a transaction, it would actually allow you to create a transaction onto the blockchain. Now, if we talk about the last three properties, that is V, R, and S, these are actually the cryptographic pieces that are derived from the private key of the sender. All right. And these three pieces can be used to derive a public key for the sender also. So these three cryptographic pieces put together actually just mean that this is the particular public key that is creating this transaction. Now, obviously, when we created our own blockchain, we just passed in the public key just as it is. All right. But this is happening in the real world. All right. So this is another security layer that is added while creating a transaction object for deployment of a contract. All right. So now the private key is actually split into three cryptographic pieces, and from that you can actually derive a public key. Alright, so that's all you need to know about a transaction object that's created for deploying a contract. So that's actually what's going on under the hood when you hit that deploy button. Alright, so now let's talk about the actual difference between the functions that actually modify a data in the smart contract and the ones that actually don't. Alright. So now we have a very nice example of both of these kinds of functions that modify our data and that don't modify our data. So we have two functions, set message and get message. So now if we talk about set message, it is actually going to change some data. All right, it's going to alter some data onto our smart contract. That is, we are going to perform some operation on the blockchain. So first things first, it's actually going to take some time to execute, because it's going to wait for its transaction to get mined onto its blockchain. The second thing is that it's going to get registered as a transaction itself. All right. So it's going to return you a transaction hash. Now, the third thing and the very important thing that you need to know is that all of these transactions that alter data are going to cost you some money. All right. That means you are actually going to pay some amount of gas fees in order to perform this operation. Now, if we talk about this get message function, which does not alter any value in a smart contract, but just simply returns a value. All right. Now this function doesn't take any time to execute. All right, whatsoever. Yes, but there would be some delay when the data is actually coming from the blockchain to you. All right. But on the blockchain, it happens instantly. All right. You don't need to wait for it to get mined onto a new blockchain, because it's not a transaction. All right. So obviously it's not a transaction. So it's not going to return you a transaction hash. And obviously it's not a transaction, and you are not performing any transaction on the blockchain. You are simply accessing a data point inside of the blockchain. So you are not actually going to pay any money for that. All right, because you are not performing any operations on the blockchain. You are simply getting a value that is getting returned from a data point inside the blockchain. So that's the difference between normal functions and view functions inside of a Solidity smart contract. So if we talk about the very important thing, for one, you need to pay money, and for the other one, you don't need to pay money because you are just simply accessing the data. So now let's talk about these types of values that I've been talking about. All right. So the first one is the actual way. All right. So this is nothing but a different unit in which ether gets counted. So if we talk about, let's say, 1 rupee, so it's equal to 100 paise. So it's just nothing different than that. All right. So one ether is actually 10 to the power 18 way. I know it's a very huge value, but that's how it is. So if you actually hit the drop down and actually see way, Gway, Fine, and ether, these are nothing but different units of ether. So you can actually go online and search for a converter for each of these types of units and actually convert ether and see how much ether each of these units are equal to. And that's pretty much it that you need to know about the units of ether. Just simply Google their value in ether and that's it. And they are just nothing different than passing ether in a different unit. So now let's just talk about this whole gas system that has been created in Ethereum. All right. So what is this gas fees that we have to pay every time we are executing something that is actually altering some data inside our smart contract? So if we talk about something other than blockchain, so if we talk about the cloud storages that are providing you servers on which you can deploy your code, all right. But the thing is that to keep your code running onto that server, you actually need to pay that cloud service. So the same thing is actually happening in here. In order to run your code onto the blockchain, you are actually paying for every operation that you perform. All right. So rather than renting out a server for a whole month and paying for it, you actually only need to pay for the functions that you run. All right. And only for the functions that are actually altering anything. So only when you are making that blockchain do some work, you are actually going to pay only for that. So now let me explain this in detail by creating a new function inside my inbox contract. So now let's talk about this new function that I have created, function do math, in which we have to pass two variables a and b, and it would perform some operations on those variables. All right. So the first operation would be a plus b, the second operation would be b minus a, the third one would be a into b, and the last one would be a is equal to 0. All right. Now, the thing is that what would I need to pay for each of these operations that I'm going to perform on the blockchain? All right, because once I deploy this and pass in two values while calling this function, so I am going to make the blockchain do some work. All right, so it's going to perform these operations, that is a plus b, b minus a into b is equal to 0 for me. All right. Now the thing is that as I am making the blockchain do some operations, I need to pay it to do that thing for me. All right. So now what is the actual cost of each of these operations? That is the plus operator, minus operator, multiplication operator, or the is equal to operator. So the amount of gas that I will be paying for all these operations is actually described inside of a spreadsheet. All right. That is actually created for us, in which we can see the amount of gas used by each of these operations. So now that I have pulled up the spreadsheet, you can actually see the gas used for each of these operations. That is the addition operation, multiplication, subtraction, division, and all the other operations that you could possibly perform on the blockchain. So the thing is that I actually have the addition, subtraction, and multiplication operations in that function, right? So I am actually going to pay 3 plus 5 plus 3. All right, so that is 11 gas for this particular function. But we also have another function that is checking the equality. All right, so we are actually checking if a is 0 or not. All right, so if we just scroll down a little bit, you can see this EQ, which stands for equality comparison. All right, so this actually also uses 3 gas. So the total amount of gas for that particular function execution would be 14. All right. So the thing is that all you need to know is that these kind of things exist, that every operation that you perform, all right, the smallest of the operations that you can perform actually cost gas on the blockchain. So obviously all these values are predefined inside the blockchain. All right. The thing is that how much do you need to pay for a single amount of gas? All right. That's something that gets varied constantly. All right. And that's due to the constant fluctuation in a particular cryptocurrency. All right, in our case, it's Ethereum. So what's the exact amount that I'm going to pay for the gas that has been calculated for this particular function? All right, so that's actually equal to the gas limit into the current gas price. So the gas limit is something that we are going to define for ourselves. So let's say that I define the gas price that I am willing to pay for this particular function as 300 Wei. So the total amount is actually simply going to be the gas limit given by me, that is 300, into the amount of gas that is going to be used for this particular function. So that is 300 into 14, which comes out to be 4200 way. And this is exactly what we mean by gas limit when we define it in our remix. Alright, so this is what it's asking for. That what is the amount of way per gas that you are willing to pay for every function execution of this smart contract. So gas is actually something that you are actually going to be coming across very frequently. Alright, because obviously the purpose of deploying smart contracts is actually that you want to obviously perform some operations over the blockchain. And where there are operations, there is obviously gas fees involved. Alright, as you have seen previously in that spreadsheet. Alright, so if you are interested in all the particular gas prices of every operation, I would actually be providing the link down below in the description and you can check out the spreadsheet for yourself. So now you must be wondering that what was the purpose of adding this extra variable into the equation. Alright, so why was this gas included in whole of this blockchain business? Alright, so the thing is that if we talk about Bitcoin and if we talk about the blockchain specific scripts, that means the Bitcoin smart contracts. All right, so they actually don't include loops. All right, and there is actually a very big reason for that. All right, so the thing is that if you don't include a gas price, then the developers would actually go wild with deploying applications over the blockchain. All right, and things would get messy within seconds. Alright, and the whole blockchain would be so crowded that it would be a tremendously tedious task to keep track of every single operation. Alright, so what Ethereum did is that they introduced this new element called gas. Alright, so this actually limits the actual development that is actually going on inside the blockchain. Alright, obviously the developers are not limited inside the test networks. Alright, you are free to do anything inside the test network. But when we talk about the actual mainnet, you don't want it to slow down. Alright, because there are actual transactions that are getting performed in there and people don't want to wait for their transactions to get mined onto a block. So now, in order to keep the developers at bay, they added this gas. Alright, so this actually limits the development that you can do with a particular smart contract. So you must be thinking that why Bitcoin didn't add loops. Alright, so the thing is that you have seen that every operation causes gas. Alright, so now just take a moment and think about infinite loops. I mean, what would happen if somebody wrote an infinite loop inside his smart contract and just deployed it and somebody else just called it? His whole account would get drained in just paying the gas fees for it. And obviously it would be an endless loop. Alright, so the whole blockchain would slow down. It would be waiting for that function to complete and then get mined onto a new block. But it would never happen. Alright, so this is the particular reason for which Bitcoin didn't add loops inside its smart contract. But Ethereum did, because it found out the other way. So it now wants its users to pay gas. Alright, and obviously it's going to check the amount of gas that you're going to be paying for every single function. Alright, so once you click transact and you see on your MetaMask that you are actually going to pay infinite gas for this particular function, you are actually going to say, peace, I'm out. So that is a huge control that has been given by Ethereum to keep the developers at bay. Alright, so this is why performing every operation onto the blockchain costs gas. So now that you have a complete understanding of what goes into creating a Solidity smart contract, we are ready to start our first project. Alright, so the thing is that I am actually not going to go ahead and talk about every single function and every single keyword inside of Solidity. Alright, because you would eventually understand it once I start using it inside our own project. So my take on this is that I am going to start this new project and you are going to learn Solidity by a practical approach, alright, by a trial and error approach, alright, which I think is best for everyone because it builds experience, alright. So the thing is that in the next video, we are actually going to start our first project in which we are first going to build our smart contract for the project that we are going to work on. So obviously, once I write functions, I would be explaining them and all the new keywords that are going to be used in them, I would obviously be going through each one of them. Alright, so you don't need to worry about that. I'll be skipping stuff. Alright, so if you are worrying about that, what is this pure keyword in here? Don't worry. I'll tell you what every keyword means inside of Solidity. Alright, but while doing so, we'll also be creating a project side by side. All right. So I'll see you in the next one. And until then, keep chilling at the Code Cove.